Good morning, everyone, and welcome to this presentation of the Indiana Statewide Imagery and LiDAR program. In this webinar, Jim Sparks, Indiana Geographic Information Officer, and Kent Park, Rupert Geospatial Project Manager, will discuss Indiana's free statewide imagery and LiDAR program, as well as provide information on available value-added services. Before we begin, I'd like to go over a few details. First, everyone on the webinar is muted with the exception of our panelists. If you have a question, please feel free to send it to the host via chat or Q&A, and we will answer it at the end of the webinar. We are recording this session, and we'll send you a link to the presentation when it is available for viewing, printing, and sharing. Now here is Kent Park to kick things off.
Good morning, everyone. Just like to take a moment to say thank you for logging into the webinar. This is a similar series as Mr. Sparks and I have presented around the state over the past few months, and just wanted to make it available to those who could not attend those sessions. So without anything else, Mr. Jim Sparks, the Indiana State GIO, will get us kicked off.
Thanks, Kent. All right, so first thing I want to talk about is a little bit about funding for this project. The project, this update has been funded for all 3 years, and that's a wonderful thing. We are talking about year 3 of this 3-year update in particular this morning, but I thought it might be worthwhile to just spend a second or two thinking about how past projects for orthoimagery were funded. The very first one you might recall came from funding from Homeland Security to Indiana Homeland Security as a result of all the activity after 9/11 in order for us all to be better prepared for events like that, for disasters like that. The 2011 through 13 funding came to us as disaster recovery funds following the 2008 flooding that affected 82 of our 92 counties. This time, though, the funding was out of the State Modernization Fund. Also, I want to point out that the columns that you're seeing in the slide on the screen should look familiar to you because this is the same sequence that we used in 2011 through 13. So we start with the central column, move over to the east, and finish this time around in 2018 in the west. Some folks have wondered, why did we start with the center column last time around? And the answer is pretty easy. We were contacted by the National Geospatial Intelligence Agency, who was looking for good information to plan for the Super Bowl in Indianapolis, realized that we were doing this project and also LiDAR, and let us know that they would be able to contribute to the funding for the project if we started with Central Indiana first, and we said sure, we'd be happy to do that. So that's how we got started there, and now we're just kind of repeating the same rotation. This time around, like 2011 through 13, this project is one that's coming out of the Indiana Office of Technology and the Indiana Geographic Information Office. I would like to give some kudos for IGIC's orthophotography work group. They were instrumental in helping to prepare the RFP, reviewing responses, and helping select Wolpert as the successful vendor for this project. As last time, the base products are 1-foot ortho images. They're geotiffs. It's 4 bands that we're looking at, red, green, blue, and near-infrared. And as much as we're able to, we're trying to make sure this is a seamless product across the state. So as everybody's using the ortho images resulting from this project, they look the same no matter where you go in the state, and it's not a hodgepodge of different specs and different standards. You probably are very familiar with red, green, and blue bands because all those together help give us a natural color. Kent's going to talk in some detail about near-infrared in just a bit, but this is an extra band that we picked up that has been particularly useful to folks who are interested in organic matter on the ground and where it is. So if you think about impervious surfaces, the near-infrared band helps with that. And also, near-infrared shows up water very well because it's my understanding that that is just an absolute black in the near-infrared band. We're very fortunate that we have a team of very accomplished and experienced photogrammetrists at the Indiana Department of Transportation, led by Chip Campbell. He and his team look over all of the deliverables. If there's anything that's found along the way, they work closely with Wolpert to find a resolution or to better understand what the anomaly is that's being looked at. I think it's also important to point out we're doing the buy-ups again. The way that works is that we have a certain amount that is being funded for the base product, that 12-inch 4-band, and we want to make sure that we recognize that sometimes our local government partners have a business need that includes higher resolutions, so either 6-inch or 3-inch, or maybe some other products that are also built into the contract. As you see in the last bullet, that could also be LiDAR, contours, land use, even applications. But we want to make sure that we leverage all the funding that might come from local governments or from that modernization fund and make sure everybody gets a win-win and ends up with the products that are most useful to their particular situation. However, the products might be purchased, and whatever they are, if it comes through this contract, then it will be made available to the public. So if you think about it as information in the public domain, that would be very close to what we're talking about here. It's very important to me that we maximize our investment in geographic information in Indiana, and for all those taxpayers' dollars, we return those products and make them as available as we can. And actually, that is one of the statutory requirements of the Geographic Information Office. So as I mentioned, the 12-inch base product is something that will be delivered to local government counties at no cost, or the equivalent amount of money that we would have spent on the 12-inch base product could be used to buy up to a higher resolution. We recognize that since we did the project in 2011 through 13, that some of the standards have changed for both ortho and imagery, and that was reflected in our RFP. In addition, how we test the accuracy of the data has also changed, and I'm not a mathematician, so I'm not going to try to explain what those formulas mean in this chart, but I will say that, again, we recognize that there were some changes, and we wanted to make sure that those were reflected in the request for proposal that went out. So that was ortho. This is LiDAR, same thing, different standards, different ways to think about the accuracy. And then this is the money slide. This is what everybody wants to know about. The base product, that 12-inch 4-band ortho imagery, is $30 per square mile. That is a cost that is covered by the state's modernization fund, resulting in zero cost to our local partners. If a buy-up is in the best interest of a local government partner, the cost of that is right around $90. There's still the $30 that we would have spent on the 12-inch, leaving right around $60 per square mile for the local government partner to pick up. Likewise, with 3-inch, $224 per square mile minus the 30 leaves $194 for the buy-up partner. Notice over at the far right 2 columns of this particular chart the cost of LiDAR to our local government partners. Love that cost. One of my early mentors at Indiana Department of Transportation would say, you know, Jim, the cheapest things in life are free. That's hard to argue with. So here's a good example of what he was talking about. Kent's going to reveal a little more information in just a minute about that. But check out the trend here. I love this. So we were, when we did the 2011 through 13 project, we were looking at $45 per square mile for the 12-inch base product. Now it's down to 30, as you saw on that last slide. 6-inch was 107. Now it's 89. 3-inch was right around $300. Now it's down to 224. So all you folks on the call, if you've got a graphing calculator, I want you to grab it now and chart this trend and see if my numbers are right. If I'm correct, it looks like Wolpert will be paying the state in about 2024 to do orthoimagery projects. And yeah, Kent's over here snickering a little bit right now, so maybe that won't happen. But the point is that what we've seen since 2005 when we did the first project is that costs continue to go down and down and down as technology improves, acquisition processes improve, and how that data is handled after acquisition all becomes more and more efficient. By the way, all the costs that I've talked about so far are assuming countywide. If one of our partners has an interest in higher resolution that's sub-county, so like a city or a town or a township, then there's other considerations that we need to think about, like its shape, the area, the configuration, how the flight lines would need to be laid out, and those kinds of things. So if you have an interest in that, please let Kent or I know about it, and we'll make sure that a calculation happens and that you receive the estimate. I'm guessing by now everybody's seen the 1-foot base product and what it looks like. Let's look a little bit closer at the 6-inch. This is great stuff. So just zooming in a little bit, you can see an awful lot in this. You can see the stripes in the parking lot with the cars. You can see different kinds of bushes around the trees. You can see some stone features and something that's in the circle there that looks like maybe a statue or something like that. A lot of information. Drilling down a little more, I can actually see pavement defects. I can see roof vents. Let's go one more step here. Check this out. You can see individual rocks in the riprap on the river, and that's 3-inch orthoimagery. If we want to think about, or that was 6-inch we were looking at, this is 3-inch. So now I can see in the bottom left corner around that curve radius, it looks like there's some kind of utility feature. See the little circle. I can't quite do what they do on CSI every week and zoom to check out the license plate number and hit the add detail button so you fill in something that was never there. But I can see an awful lot of information. I can see the aluminum reflectors on the tennis court lights, for example, and actually see the posts in the fence line on the tennis court. So great information. What we found so far is that people who want 3-inch resolution are likely to be especially interested in the utilities because the outcroppings do show up so well with this. But you may have other business reasons that require this higher resolution imagery. So as a reminder, we did the central column in 2016, this past acquisition season, which was a very challenging one because of the crazy spring we had in Indiana. We're over on the east side of the state. That's all been acquired, plus 4 counties that were in the south central column that we couldn't pick up last year because of the flooding in that part of the state. And we're here today to focus in particular on the western column that will be acquired beginning something like middle of February next year. So just a reminder of what we're looking for acquisition is starting sometime in February during the hours of the day when the sun angle's high enough to reduce really to make sure the shadows aren't quite as severe and not quite as harsh. We don't want snow on the ground. We don't want rivers to be up out of their banks too much. We don't want leaves on the trees, so we have to shut things down sometime in April. We don't want cloudy weather because we want to be able to see what's on the ground. And think about the very, very few days that we have in the springtime where all those conditions are met. And sometimes even that's not enough. In 2011, when Marion County was being acquired, all of those conditions were met. The pilot was in the plane, in the air, on a flight line over Marion County, and the wind speed, the wind turbulence where the plane was just too great. The plane was kind of rocking around, and the sensors went off to let the folks know that this is not really producing the quality that we're looking for. So pilot put back down, went back up later in the day, same thing, landed again, and it was not until several days later that we were able to finish up Marion County. So I'm glad it's not my job to figure out the logistics of how to get all this work done in a very, very short time frame, but Wilford does a great job at doing that. I think with that, Kent, I'm going to turn it over to you.
Okay, thanks, Jim.
You're welcome.
We will wait until after all the slides are complete here to go through any questions. So if you have any for Jim or anybody, his presentation, please hold those for now, please. One of the questions that I get asked often is how many drones do we use to acquire the imagery? We don't actually use any drones. Wilford has a fleet of full-size aircraft. This is a example of a Cessna 404 that we use. Currently have several 404s and 406. Those are our workhorse. And just to give you an idea of what the inside of it looks like, the bottom center picture shows the camera configuration with the operator and his computer sitting behind the camera controlling that during the flight. The left side there of the screen shows some of the technical specifications of the actual camera system and what it captures, along with a LiDAR sensor. All of our aircraft are what we call a dual port. We buy a perfectly good aircraft, cut all the seats, and cut two holes in the bottom of it, one to put the camera in and one to put the LiDAR sensor in. So this is a typical camera configuration used for the project. As Jim had mentioned, we are collecting multiple bands. One that he didn't mention is a band chromatic or black and white. That is one of the bands captured, and we use it in some of our pre- and post-processing algorithms, but it is not an actual deliverable. From there, though, we get into the red, the green, and the blues, along with the near-infrared. The red, the green, and the blue, as Jim already mentioned, are what we normally see. When we get into actually viewing the imagery, that gives us our true color pictures. Those individual channels, though, allow us to do a lot of post-processing of the data and extract out additional features through remote sensing techniques. And I'll go into some of those benefits later on. And again, here's the near-infrared. As Jim had mentioned earlier, this allows us to see vegetative features, which our normal flight time, there aren't any, or not much on the trees and bushes. We're more interested in the vegetation that's on the ground level, such as grasses and swamp areas, things like that. So this NIR band actually helps us see a lot of the low-level vegetative features that are acquired. As Jim had mentioned, this past spring we acquired the eastern third of the state. We did have a few outliers down in the central part of the state that due to flooding didn't get flown in 16. And then we had one county that for business needs needed to buy up this year to a 6-inch image product to suit their needs, so we were able to accommodate them. We did have a pretty good spring. We actually, with the strange weather we had in January, did a little pre-planning early February with Jim, looked at the sun angle and received permission to actually start acquiring imagery about the 3rd or 4th of February. And what that allowed us to do is for all the buy-up imagery, which is priority, we were able to complete all of that by the middle of March. But all of the imagery was acquired this year prior to April 1st, way before we had any leaf out or had to worry really about any leaf conditions across the state. So it was a really good year for us to fly. An overall project schedule, this gets kind of recycled year to year and is what we use as a baseline project. As I mentioned, we have a planning meeting in January, and our ground control and acquisition phases both start in February. As Jim mentioned earlier, key to the acquisition is no leaves on the trees, no snow on the ground. Hopefully all the water and flooding is gone at that time. We also look for things like fire and haze, smoke, things like that that are created on a local level that we have to go back and refly small areas because we want as clear and crisp imagery as we can possibly have for the final deliverable. We also step through some of our processing phases here in the middle months of the summer and start our actual delivery to the state of the pilot project early summer, give them a little bit of time to review it with the production workflow continuing throughout the fall, and hopefully have everything delivered by the end of October. This year, though, was a little strange because we're also contracted to acquire LiDAR across the state. And for the production of orthoimagery, we need an up-to-date and accurate surface, and that's what that LiDAR data creates. So we have acquired both the imagery and the LiDAR for the eastern tier, and the same will happen next year for the western tier of the state. We're going to process that LiDAR to a point where we can use it for a base. So our imagery project will actually be somewhere between May and June, kind of come to a halt for about 60 or 90 days while we process that LiDAR data and then ingest that into the system to make better orthos. What that will do is on this overall schedule is push it out 2 to 3 months. When we approached the state, Jim and his partners at INDOT thought that was a great idea to make use of that more recent and more accurate LiDAR data, and we're able to accommodate the schedule and pushing that out in order to allow us to process that. Delivery. All the data in the past had been delivered on hard drives. It kind of created a large logistics nightmare because every time we would write a hard drive and then ship it, it might sit on somebody's desk for a few days before they got it loaded on their system and reviewed it and then ship it to another destination, etc. So what we saw is from the time we actually completed a county back in 2011 through 13, it might be 4 to 5 months before the county received that data. So with the 2016 through 18 project, we've taken a different approach, and that's delivery via the cloud. So once we've sent the data out to INDOT, they've approved it all, we come back and take the data, package it into its final delivery products, and then we load that up to a cloud-based host provider, if you will, and each county then is sent a link with a password, and they can then download that data on their own time, if you will. From our test of the 2016 season, it took anywhere from 8 to about 16 hours, and it's really dependent upon the local bandwidth that you have access to. Just as a reminder, so there is one deliverable that goes to Jim's office at the state and one per county. If a county or municipalities need additional, we will work with them to provide additional downloads, but the way that the current password system is set up, it is one download per county and one for the state. That's kind of where we're at in the imagery program. As I mentioned, we have this LiDAR program that was actually put together over the course of the past year and has a couple of major partners that have kind of worked very, very feverishly to get it thrown together and get it out. The IJIC Elevation Work Group saw it needed in the northeast part of the state. We were contacted by the state of Ohio to deal with what we call the Lake Erie algae bloom, and they were wanting to monitor the entire watershed that drained into the Maumee Basin, which then goes into Lake Erie. So there was a 7 or 8 county area identified early on, and USDA along with IJIC and the GIO's office all saw the need for it and started putting together funding to see how much of that they could do and to what accuracy could be done. Luckily, through some insight of USDA and how they could use LiDAR in other areas of the state, that program gained momentum. And what we have now is USDA, through the local Indiana office of NRCS, was able to fund a statewide LiDAR data set that will be acquired in 2017 and 2018. The picture up here shows the various years of the previous LiDAR. The new LiDAR will actually follow the state plane coordinate system. So Indiana is divided into east and a west state plane coordinate system. The eastern portion of the state was about 95% acquired in this past spring, and the rest of that will be acquired in the January timeframe along with the western state plane coordinate system. But this will be to the new USGS quality level 2 accuracy, which is 2 points per meter, with an actual vertical accuracy of somewhere around 9 to 10 centimeters vertical accuracy across the entire state. Here's a slide shot again showing how the state is divided in two. The 11 county area in the northeast is what, by contract, USGS has determined is the priority area, and that is due to be delivered mid-summer of 2017. The eastern half of the state in green, again, the majority of that was acquired this year. That will be delivered before the end of 2017 to USGS. And then the remainder of the state, the western in pink there, will be acquired in 2018 and delivered late 2018. The 3 counties in blue were actually a separate USGS contract, and 2 of those counties, Hamilton and Marion, were acquired in the spring of 2016, and Wayne County was acquired, again, through a separate USGS contract in 2017. They weren't reacquired as part of the statewide effort. As I mentioned earlier, we can take the individual red, green, and blue channels along with the elevation data, and through some really creative processing algorithms, we can now automatically extract features out and make intelligent use of the data. And that's where we're getting as an industry, is rather than just looking at pretty pictures or points on the ground as elevation data, now we're trying to figure out, and we've actually accomplished it, is what can we do and what can we make it accurate. So we're actually able to extract out buildings. Right now there's a talk of the state looking at doing all buildings, all structures greater than 100 square feet, and providing that as a data set across the state. And there's other applications that need an elevation of that, such as FEMA would like to know the elevation of the lowest point of entry of every building. And again, between the imagery and the LiDAR data sets, we can extract out this kind of information and deliver that product out. We can also, through the LiDAR, pull out terrain modeling. So we can not only show the actual relief of the ground in a 3-dimensional model with the imagery on top of it, we can also pull out the buildings and show their 3-dimensional so you get a perspective. Very, very valuable in things like cell phone, along with windmill locations. Can also be used for a lot of real estate applications where line of sight, things like that, are of importance of not blocking someone's views. As Jim had mentioned earlier, the impervious surface, seems to be a big push for that across the state, where people are wanting to know better where their impervious surface areas are, so that they can then create accurate tax maps and assess the individual parcel owners of those surfaces. Again, we use the red, the green, the blue, but mainly the near-infrared band, along with the LiDAR data, pull all that out. And it starts looking at pixels, and it looks for nearest common pixels, and it grows on that, and then before you know it, you've got this nearest common pixel turns into a building, or it might be a parking lot. And then when we apply the LiDAR data to that as a validity, we can go through and look at it and say, okay, yes, these nearest pixels are very, very common, and that would be surface such as a parking lot or the roof of a building. We can ingest your existing land use mapping and produce a cover map showing which areas are vegetative, swamps, rivers, streams, hard surface such as roads, buildings, things like that, and also extract that out and provide it back to you to validate your land use mapping, or to be able to provide an update to your land use mapping. Hydrology. The state of Indiana recently completed a statewide hydrology layer data set through IGIC. It was the first state in the country to be to this level, and while it is complete, our hydrology due to shifting streams of rivers is constantly changing. This used the old LiDAR data, and using the new LiDAR data, there will be some shifts also just due to the accuracies of the LiDAR data sets. So again, it's an ongoing process of keeping this updated, all the stream network across the entire state, but through the imagery and the LiDAR, another use of this very valuable data provided by the state. Another one would be extracting out forest mapping areas. Excuse me. Again, we can use that near-infrared band to pull out the forest. We can also use it to pull out from the LiDAR data set the hard surfaces such as building and roads, and show the difference in those areas. Change detection, here's another good use at the local level. A lot of the assessors, along with the 911 folks like this, we can tell where a building may have been added onto or built. We can also tell though where they've been taken down, so response needs or assessment needs can be looked at and addressed in those specific parcels. Again, I'd like to thank you for joining us today. Erin?
we'd like to open it up for any questions at this point.
So feel free either via the chat room or via speaker. Everybody has been unmuted. If you'd like to have any questions or need anything answered further.
Yeah, I think all my questions have been answered.
Good.
I wasn't able to make it into the meeting, so I checked this out and looks good. So we're thinking towards the fall for the delivery.
Yeah, we'll actually start the final deliveries hopefully sometime in August or September. And where we're using the new LiDAR data set, those will get pushed out a little bit later, but we hope to complete by the end of December, have every county delivered by the end of December of the year.
Okay, all right. So I guess I'm from Adams County, so would the LiDAR probably come with the aerials, I would guess?
Well, the aerials are through the state, and that's one contract deliverable. The LiDAR data being through USGS contract vehicle. Mm-hmm. And they have a little bit different as far as their delivery process. To be 100% honest, we're still talking with them. We are going to try to deliver them as close as possible. But USGS usually likes to review those on their own before they're delivered out to the county. And we're trying to see how we can accommodate and maybe get their review process up to speed with the states on the imagery side, so that, you know, we don't deliver a county image product in October, but then it'd be 6 months later when we get the LiDAR data. Our goal is to work with USGS and try to get those as close to the same time as possible. Okay,
sounds great.
You know, this is Jim. As Kent pointed out, these are two different projects. So ortho coming through the Indiana Office of Technology and the Geographic Information Office, LiDAR through USGS as a result of a proposal from IJIC and funding from NRCS, and that sounds like a lot of partners, and it really is, but that's a very cool thing. Sometimes I hear people in other states talk about how lucky we are in Indiana when it comes to GIS, and there's no doubt that we've had lots and lots of fortunate events in our past that helped get us here, but I also like to think about luck as a philosopher from ancient Rome once said, luck is when preparation meets opportunity. Our very engaged GIS community in Indiana does the work to be prepared for when an opportunity presents itself. And Kent's story about the algae bloom in one of the Great Lakes and how that led to a project proposal, and how that led to some funding, and how that all helps give us a new way to look at the Earth in Indiana, and also augments, facilitates, improves the ortho imagery. I think that whole thing is an excellent way to communicate that we are lucky in Indiana in large measure because we do the preparation and we're in the right spot for when the opportunity comes.
I don't think I have any more questions, guys. I appreciate it. Thank you very much.
Okay, well, we'd like to thank everybody for joining us today. We'll leave this slide up there a little bit longer with our contact info. And later on today, this webinar will be provided on the Wolpert website. So if you want to send it out to anyone who wasn't able to attend, or if you know of somebody, they can still be able to view it and get the information from it. Again, thank you for attending today. I appreciate your time.